Good morning, welcome to Sakala Vijay YouTube channel. So now welcome to the Diploma Semester 1 Basic Engineering Mathematics classes. In this session we discuss Matrices chapter. This very important chapter, useful chapter. Even it's very important for even ESET examination also. Even for EAMCET examination. Matrices. Weightage is 6 marks. The examination. But in intermediate it has more weightage. More than 30 marks. Okay, welcome you all. Matrices. First, the definition of the matrix radar. Definition. Definition of the matrix. Definition of the matrix. Definition of the matrix. So what is the matrix? Actually, the matrix is the arrangement of the numbers. It is an arrangement. So actually, the numbers are arranged in a rectangular array. The arrangement is called matrices. The numbers may be real numbers or complex numbers. If the real numbers or complex numbers are arranged in a rectangular array, then that is called matrix. So that means matrix is called a set of numbers, a set of numbers, a set of numbers, real or complex. It may be real or complex numbers. Real or complex, arranged in the form of a rectangular array having rows and columns. Rows and columns. Rows and columns is called a matrix. This is the definition of the matrix. So you may be asked in the examination also. Write the definition of the matrix. A set of numbers, real or complex, arranged in the form of a rectangular array having rows and columns is called a matrix. So examples we shall give as many as examples. So first example, 2, 3, 4, 5, 6, 7. Okay. Second example you take like this. Sum A1, A2, A3, B1, B2, B3, C1, C2, C3. Third example, I complex number 0, 1, 2, minus 3i and 4. So you can use this bracket, or you can sometimes use these brackets also, no problem. So you can write like this also, examples 1, 2, 3, 4. This bracket also we can make use of. So that means actually you see here in this case, this is called first row, row 1. This is called second row. This is called third row. So now this is called first column, column number 1. This is called column number 2. Here the column number 1. Here we have column number 2, column number 3. Suppose these are called row number 1, row number 2, row number 3. Here this is row 1, first row, this is second row. So now this is first column, this is second column, this is third column. Here first column, this is second column. So it has how many rows? 2 rows, R1 and R2. So now I ask you one question. How do you count rows and how do you count columns? See, rows are counted like this. See, first row, second row, third row. That means the first matrix is consisting of 3 rows. First row, second column. Left to right, you need to count the rows. So top to bottom, 1, 2, 2 columns. So that means first matrix contains 3 rows, 2 columns. Now I ask you one question. In second matrix, how many rows and how many columns are there? 1, 2, 3 rows and 3 columns. In third matrix, we have 2 rows and 3 columns. In fourth matrix, we have 2 rows and 2 columns. And one more thing, this is horizontally, this vertically. That means the horizontal line of numbers are called rows. Vertical lines of numbers are called columns. So now the 2, 3, 4, 5, 6, 7 are called elements of this matrix. A1, A2, A3, B1, B2, B3, C1, C2, C3 are also elements of the second matrix. I, 0, 1, 2, minus 3, I, 4. That means entries of a matrix are called elements. So let us write our observations. Let us write observations. So what are the observations that we have? Let us write one by one. First observation. The horizontal lines of numbers is called rows. So next, the vertical lines of numbers is called columns. Rows and columns. So next, actually the numbers are entries in a matrix are called good morning are called elements of a matrix. Generally they denoted by small letters. So such as A, B, C, D and so on, or A1, A2, A3 and so on dash. Next observation, the fourth observation. So now the matrices, the elements of the matrices, are enclosed between this kind of brackets, this bracket or this bracket, called parenthesis. So now matrices are denoted by capital letters, that is capital A, capital B, capital C, and so on, X, Y, Z. A matrix, B matrix. Example we can write like this. A equals to 1, 2, 3, 4, minus 5, 0. Don't put the commas between this one. Elements are of a matrix are enclosed between the bracket, this bracket. So now denoted by the A matrix. It's called A matrix. How many rows? 3 rows and 2 columns it has. Second example, you can write matrix B equals to, you use this one also, 2, 0, minus 5, I. This is also matrix. So matrix is denoted by the capital letters. So understood now. So and one more observation. The rows of a matrix are counted from left to right. Sixth observation. The columns of a matrix are counted from top to bottom. Top to bottom. 1A, 1B already completed, Nana. That will be available in the playlist. Just type, go to the Sakala Vidya, type Sakala Vidya, enter 1A, enter 1B. All the chapters have been completed. You can go through them. Okay, next definition. So next definition is order of a matrix. So this is also very important. You may be asked in the examination. Write the order of a matrix, or type of a matrix, or size of a matrix. See, you remember order, type, size. In the same sense we use order of a matrix, type of a matrix, size of a matrix. Same definition. That's the order of a matrix. What is the order of the matrix? For example, see, the order of a matrix can be determined by using the number of rows and number of columns. So that means the number of rows and columns present in the matrix called order of a matrix. The number of rows and columns present in a matrix is called order of a matrix. Order of a matrix. So now note writer. If there are m rows and n columns in a matrix A, name of the matrix is A, in matrix A, then the order of A is given by m by n. You need to read it as m by n, but you need to write into mark. So Vinuta, welcome, good morning. M by n matrix, m by n type matrix. So now let us discuss examples now. Examples. First example. Consider A equals to 2, 3 minus 4, 0, 1 minus 5. So what is the order of A? See here, write down number of rows. Number of rows is equal to, how do you count number of rows? Left to right, 1, 2. Number of rows is 2. Now number of columns, you count it. Number of columns is equal to 1, 2, 3. So therefore order equals to order of A equal to 2 by 3. Generally you write order here 2 by 3. Order of A is 2 by 3. Very good. Second example. Matrix B equals to -1, 0, 3, 2, -5, I. See here, number of rows equals to 1, 2, 3. 3 rows. Number of columns equals to 2. Order equals to, what is the order? We can write 3 by 2. Generally we mention order like this. This is 3 by 2 order matrix. Okay, now I am going to explain the matrices. That will be useful to you, na? Yes. So now you go to another example. C matrix 2, 3, 4, 5. Here write down number of rows. How many number of rows are there in this matrix C? 1, 2. 2 rows. Number of columns is equal to 2. Good morning Devendra. Good morning. Okay, straight line. I will discuss later. Next, order equals to, we can say 2 by 2. This is 2 by 2. This is also called second order matrix. 2 by 2 means second order matrix. Second year matrices, second year maths. Okay, that also I will deal. This is 2 by 2 matrix. Let us go for another example. Matrix D. A1, B1, C1, A2, B2, C2, A3, B3, C3. So now write down here number of rows. Number of rows is equal to 3. Number of columns Number of columns is equal to 3. Now order is equal to 3 by 3. Very good. Order equals to 3 by 3. This is also called third order. Third order matrix. So we write 3 by 3. Its order is 3 by 3. Okay, now let us come to next important concept. General form of a matrix. What is the general form of a matrix? So the matrix, the whose order is m by n, is termed to be a general form of a matrix. So general form of a matrix means, for example, you take like this. General form of a matrix, A equals to, you write down like this. This is A11. These are called suffixes. First suffix, second suffix. First suffix indicates, I will explain later, don't worry. This is A11, this is A12, this is A13, okay, and so on. We can write A1J and dash dash A1N. Next go to A21, A22, A23 and dash dash A2J dash dash A2N, and so on. You can write A31, A32, A33 and so on, A3J and dash dash A3N, and it will be continued like this. Now it will be continued like this. You write down AM1, that means M rows. This is AM2 and so on, AM3 and so on, AMJ and so on. This we can write AMN because there are MN elements. This is M by N. So this is actually column. This is the first column. So first column, first row, row 1. This is row 2. This is row 3. And this is actually row M. Row M. How many columns? This is first column. This is second column. This is third column. This is actually jth column. CJ, jth column. This is nth column. Cn. There are n columns and m rows. M rows. This is m by n matrix. M by n matrix. This is called general form of a matrix. So that means first row elements are, this is the A11, A12, A13 and A1. Similarly first column A11, A21, A31 and M11. So now nth column A1n, A2n, A3n, AMN, like that you can write. What do you mean by A23? For example, A23 means this is the element in second row and third column For example, if I say Aij, what do you mean by Ij? This is the element in ith row and jth column. This is called general element. Instead of writing this very lengthy manner, we can write in compact form also. That is called compact form of a matrix. So now, note write down. The element which lies in ith row and jth column is denoted by Aij. Aij. That means first suffix, this is called I. First suffix I denotes row. I denotes row. Second suffix J denotes column in which the element lies. So that means now we can write is compact form of a matrix. Compact form of a matrix. Compact form of a matrix. What is the compact form of a matrix? Means A is equal to, we can write Aij like this, m by n, where we can define m and we can define n, where 1 less than or equal to I less than or equal to m and 1 less than or equal to j less than or equal to n. So instead of writing very lengthy manner, so elaborate manner, simple concise manner you can write. This is called compact form of a matrix. With the help of the compact form of a matrix, we can prepare as many as matrices. Okay, one example I will discuss. One example. Write the matrix A is equal to Aij is 2 by 3. 2 by 3 means second order, second row, 2 rows and 3 columns. 2 rows and 3 columns. Where Aij equals to I plus j. This definition is given. Now you need to construct the matrix. How do you construct? Let me explain. So now here solution, very easy manner you can find out. I take the values from 1 to 2. So that means you need to take like this. I is equal to 1 comma 2. Whereas j take the values 1 comma 2 comma 3. So now, first write down A matrix, general matrix write down with the help of this one. 2 rows and 2 columns. That means you will be getting like this. A11, next A12, A13. Next A21, A22, A23. Now you need to find out A11. A11 means A is equal to I plus j. 1 plus 1, 2. Next A12, 1 plus 2, 3. A13, 1 plus 3, 4. A21, 2 plus 1, 3. A22, 2 plus 2, 4. A23, 2 plus 3, 5. So substitute. Therefore, this equals to, we get like this. 2, 3, 4, 3, 4, 5. This is 2 by 3 matrix. So good morning, Rajum. Okay, now I will give one more example. You try to solve it now. Find matrix A. Equals to Aij of 2 by 2 where Aij equals to I square plus j square. Can you find out? Can you find out? Can you find out? So second order matrix we need to find out. See now the solution. First write down here A equals to general matrix, write down 2 by 2 matrix A11, A12, A21, A22. Now we need to define A11. See, A11 equals to I square plus j square. 1 square 1, 1 square 1, 2. Define A12. 1 square 1, 2 square 4, 5. Now A21. Define A21. 2 square 4, 1 square 1, 5. A22. 2 square 4, 2 square 4, 8. So therefore the matrix A is 2, 5, 5, 8. This is 2 by 2 matrix. That means we have constructed accordingly by the given definition. You can find out. That is the use of the compact form. That is the use of the compact form. So very good morning, Devendra. Okay, leave it now. This one now. It's very important is types of matrices. Types of matrices. Types of matrices. This is very important. Types of matrices. So very important. Definitely for 1 mark you may be asked the definition of the types of the matrices. Please note down one by one. First one is rectangular matrix. Rectangular matrix. Rectangular matrix. So what do you mean by rectangular matrix? So rectangular matrix means actually if the number of rows or number of columns are not same, not equal, then they said to be the rectangular matrix. So that means a matrix in which the number of rows is not equal to the number of columns is called a rectangular matrix. Rectangular matrix. So this is the definition of the rectangular matrix. This was given October examination, October 2017 examination. This was asked. Okay, now you can write example also. One example you shall give it now. So example. A equals to 2, 3, minus 5, 0, minus 1, 2. See how many rows are there? 2 rows. How many columns? 3 columns. 2 is not equal to 3. So number of rows is not equal to number of columns. So this type of matrix is called rectangular matrix. It seems to be rather in the shape of rectangle itself only. So it is called rectangular matrix. And one more note, important note. Let A be a matrix of order m by n if m is not equal to n, then A is said to be rectangular matrix. Rectangular matrix. So like this also we can say, if A is a m by n matrix, then if m does not equal to n, then A is said to be a rectangular matrix. Rectangular matrix. So next let us move to the second one now. Second one. Square matrix. Now easily you can define square matrix. Are you able to define the square matrix? What do you mean by square matrix, Nana? What do you mean by the square matrix? It's very good, Santu Santoshini. Very good. A matrix in which the number of rows is equal to number of columns. Is called a square matrix. Yes, square matrix. Now example, A equals to 2, 3, 4, 5. Number of rows 2, number of columns 2, 2 by 2. Another example, B is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. This is 3 by 3. So note write down, important note. A matrix A m by n is said to be a square matrix if m is equal to n. If m does not equal to n, that is rectangular matrix. Yes, morning class you might have not seen Pavan Sai. I explained shortcuts, lot of shortcuts. Here also in this I will discuss shortcuts. So now go to the third one. Third one is row matrix. What is meant by the row matrix? So row matrix means it's just like a row. A matrix having only one row. Number of columns may be different. That is called row matrix. Row matrix will be in the form of 1 by n. Row matrix. A matrix having only one row is called a row matrix. Row matrix. Good morning, Sai Krishna. Okay. It is in the form of 1 by n. 1 by n type or order. Example, A equals to 1, 2, 3, 4, 5. How many rows are there? Only one row. How many columns? 1, 2, 3, 5 columns. 1 by 5. Another example you take. A, B, C, D, dash, dash, Z. 1 by 26. So these are called examples for row matrix. Row matrix. Next, fourth one. Definitely Pawan Sai, after completion of this session, offline session, you can ask the doubts. Right, WhatsApp also. So fourth one. Right. Column matrix. Column matrix. Column matrix. Can you define column matrix? What do you mean by column matrix? Column matrix. Anybody? Anybody? I will wait. Sai Krishna, Pavan Sai, Santo, Pradyumna, Tarun Teja. What is meant by column matrix? Having only one column. Very good, Nana. Very good. A matrix having only one column is called a column matrix. It is of the form m by 1 type. So examples A equals to 1, 2, 3, 4, 5. That means see 1, 2, 3, 4, 5. 5 columns, 5 rows and 1 column. Second, B. A, B, C, dash, dash, Z. Total there are 26 rows, 1 column. 26 by 1. Next, fifth one. Null matrix or zero matrix. Null matrix or zero matrix. So what is the definition of the null matrix and zero matrix? Anybody? a matrix in which all the elements are equal to 0, then it is called a null matrix or zero matrix. Otherwise you can say like this: if all the elements of a matrix are equal to 0, then it is called a null matrix or a zero matrix. All the elements are 0. Very good. Generally the null matrix, zero matrix in this chapter denoted by the letter O. O stands for, that's null matrix, but its type or order will be changed problem to problem. So this is the additive identity, also we can call it as additive identity. Null matrix or zero matrix. See, that can be defined like this: if all the elements if all the elements of a matrix, yes, of a matrix are equal to 0, then it is called a null matrix or zero matrix. So one more note, write down, that's very important. A null matrix of order m by n is denoted by O, not 0, O, m by n. There are m rows and n columns, but every element is 0. So that means, for example, see, example O2 by 3. O2 by 3 means you need to write like this: 2 rows and 3 columns. 2 rows and 3 columns means 0, 0, 0, 0, 0, 0. This one example. O2 by 2. O2 by 2 means 2 rows and 2 columns. 0, 0, 0, 0. Like this. This order depends upon the context itself only. Depends upon, it changes problem to problem. So now few important concepts need to be discussed before going to discuss next type of the matrix. So let me discuss what is meant by the principal diagonal. That's very important. Principal diagonal. Next we discuss trace of a matrix also. Right. Next, principal diagonal, next concept. Next, note write down, that is note. In this note, first point, principal diagonal. Principal diagonal. So what is meant by the principal diagonal? So principal diagonal means in a square matrix, only we define. In a square matrix, all those elements Aij for which I is equal to j, that is A11 first row first column, A22 second row second column, A33 dash dash are called principal diagonal elements of a square matrix My dear children, please remember, principal diagonal is confined to the only square matrix. I will show you, don't worry. What is the principal diagonal? So example, you consider example A equals to 1, 2, 3, 4. See, can this be a square matrix? Yes, it is 2 by 2. So principal diagonal elements means this is principal diagonal elements. This is called principal diagonal. Principal diagonal. Principal diagonal. Principal diagonal. Okay. Let us consider another example. B is equal to 1, 2, 3, minus 1, 0, 4, 0, 1, minus 1. This is 3 by 3. See, the principal diagonal elements are this one. These are called principal diagonal elements. Principal diagonal elements. Okay, you can watch. Right. This is principal diagonal elements. So next now, second note. Note 2. Trace of a matrix. This is very important concept for competitive entrance examination point of view. What do you mean by a trace of a matrix? Okay. The sum of the elements of a principal diagonal in a square matrix is called a trace of a matrix. This is the definition of the trace of the matrix. So now let A be a square matrix. Then trace of A is denoted by TR of A, trace of A. So let us discuss one example now. Find the trace of the following matrices. First matrix A equals to 1, 2, 3, 4, 3, 2, 0, 0, minus 4. Second diagonal. This is the principal diagonal. This is the principal diagonal. That means 1 plus 3 plus of minus 4. So 4 minus 4. 0 is the trace of this matrix. So could you find out trace of B now here? Solution. Trace of B. What is trace of B? This is called principal diagonal. That is 1 plus 4 is 5. So this is called, actually you remember, this is called other diagonal. Two diagonals it has. This is called other diagonal. Other diagonal. Now next type we need to discuss now. Next one is sixth, diagonal matrix. Diagonal matrix. What is meant by diagonal matrix? So what is meant by diagonal matrix? Anybody? So what is meant by the diagonal matrix? So diagonal matrix means it's absolutely square matrix only if all the elements of a square matrix are zeros except in principal diagonal. That means only the elements are present in principal diagonal elements, rest of the elements are zeros. Then that is called a diagonal matrix. That means we can define like this: if all the elements of a square matrix are zeros except those of the principal diagonal. Then the matrix is called a diagonal matrix. So this is the definition of the diagonal matrix. So example, let me give an example now, because in the examination you are asked to write even examples too. Example: A must be square matrix 2 0 0 0 5 0 0 0 minus 3. See, except principal diagonal, rest of the elements are 0. So this is called a diagonal matrix. Example for a diagonal matrix. Okay, tomorrow we shall move to remaining types of matrices, and after that we shall continue this chapter. This chapter is very, very important for intermediate, second year also, intermediate also, very, very important. It will be useful for all competitive entrance examinations. Thank you. Bye bye.